Last year, somebody stood up at the last session and said, I'm entering data all the time, but I really think I could do my job better if I had a better understanding of how it's used, what it looks like once it leaves my, the data entry process, including even what's a primary key. And that kind of just slapped me upside the head, because I know policymakers don't even think about databases beyond maybe Excel, and they don't want to talk about that either. But what's this huge gray area in between, and how do we make sense of it? How do you make sense of it so that you help us along the way? And the panel this morning brought up excellent examples of why data quality, data integrity matter. It's going to cost you millions if there's problems. So, basic tenet of database design, build it with the user in mind, which is great if we are just now building a data system around student information, right? But as Philadelphia said, they've got a 25-year-old system. I can't even imagine what that looks like right now and how many Band-Aids it has on it. So we're using data systems that are very old. We're building new data warehouses, but as you all know and live, the data world changes daily, certainly yearly, as the feds and the states change definitions, change categories and stuff like that. So we've got to be pretty nimble. So build it with the user in mind, but also adapt it with the user in mind. Think how the data will be used. We want to address, let me go ahead. So build it with the user in mind, think how it's going to be used. Right now, we've got so many different databases built so long ago and so many different users. I'm not used to this automation thing. We've got so many users. It's not just compliance. We're not just collecting data to send to the states, to send to the feds, and nobody ever knows if the feds used them or not. I did spend a year at the feds. I promise you people do look at the data, but I wasn't convinced until I got up there. There's a lot more uses. Again, not just compliance. The whole point of this, more than compliance, and more connections across different databases. When you think about it, just at the state education agency, this is just a sample of the types of data that the state education agency collects. Some from districts, most from districts, but a lot of different sources. Course completion, the organization, all the details about the district, about every school. Finance, and this was something for the past, 10 years ago, policy people didn't know that the finance data system was totally different from the student information system. I mean, like Mars and Venus, so it wasn't easy to tie them together. Staff, student assessment, there's a gazillion more different types of data sets, data sources coming into the states. And you all know in the districts, again, just a small sample, you've got your SIS, your grade book, your finance, your curriculum, transportation, food services, library. Probably you have a gazillion different user interfaces, one for every data source, probably with a different sign-on, and I apologize for that. I know a lot of people are trying to get to single sign-ons, but it is a lot of work to enter in all the data in all the different data sources. And by the same token, it's a lot of work to try to bring it all together and connect it. And we're just now really getting the gist of how to do that, to really effectively use the data. When you think about the different types of data collections, there's a lot of different ways we get the data. Student level data, sometimes it's aggregate. The CSPR reporting for the feds, all the different federal title program. A lot of that is just handwritten, verbal, open-ended. You've got aggregate, you've got web-based, you've got paper and pencil, you've still got Excel files in many places. You've got annual, daily, some states are moving to daily student information systems. It's all over the place. So managing it, I will say, the PDE folks and I know the district folks, there's a reason everyone looks tense and tired just trying to manage all of this. And then pulling it all together into one usable system to connect the data and try to figure out, well, how many kids are using the library and how does that affect their achievement? What's happening with the transportation, the busing system, and how do we get kids on time, and how's that affect their achievement? Because despite what he said last night, achievement is really what we talk about the most. How do we pull all of this together? And what are the risks if we don't? As was mentioned earlier, there's a lot of money tied to this. Just basic average daily attendance rates is what gets the districts a lot of their money. When 10 years ago we started talking about creating student-level data systems at the state, a lot of states told me, the state education agency people around the country, well, we've just been getting aggregates from the district. What if we now get an accurate count and we get less money because we're overcounting students? By the same token, what if you get another million or two because you have an accurate count? You cannot easily find the information. As I was developing this PowerPoint, a friend of mine in Texas, full disclosure, I live in Texas, so I probably make too many Texas references for other states' pleasure. But anyway, as I was creating this, a friend of mine she and I worked at the Texas Education Agency, she was in performance reporting, knows their data reports up one side and down the other, said that she spent hours to find just the number of students enrolled in charter schools and found it on page 231 of a report. There's no need for that. But that's a lot of people who are creating reports they don't understand the use of data, and they're just checking off checklists and putting reports and putting it out there and saying, oh yeah, we've made it all public. If it's not easily findable, then you can't use it for decision making. What another risk of bad data design, database design, bad data, as they mentioned earlier, how do you plan for all the teachers you need, the specialists you need? How do you plan your resources if you don't have accurate data? I thought the example of Reading District was pretty mind-boggling to think of how little they were using data and the consequences that came of it. I'm talking fast because there's a lot to cover, but I just also want to put a plug in case I don't get to everything, or even if I do and you want to hear more in more detail. There's a session Wednesday at 11 a.m. that will really go into data quality and data analytics in more detail. And even though I'm talking fast, please, if you have questions, interrupt me, because this is for you. We need to make sure we meet your needs. So basic database design or data system, and I will say that you remember, everyone old enough here to remember that whole what is, how do we define whatever it is we're talking about? To some people, a database is a simple Excel table, Excel sheet. It has rows and columns and lots of numbers in it. To some people, a database, that's just a data set, and the database is all the different data collections that you have. It's the whole system of data collections. All of those are right. So we're going to go through just the process or just some of the thinking around the database design. Basically, a database, a data set, has a table, Excel, SQL, whatever source you want to use. And each table is a database in and of itself. That's a student data table. It has one type of data, like student, staff, organization, finance, or a database. The whole data system describes a collection of tables. When we started the data quality campaign years ago, we started talking about a statewide longitudinal data system, which to me means all of the databases, all the data sets, all the data sources. A lot of people use their federal grant money to create a data warehouse, and they call that warehouse the data system, and don't think about all of the other things that don't outside of the student information system. We're all kind of right as long as we're talking about data and get the whole big picture. Large database systems, as I said, have many different tables, each with a distinct type of data in them. Enrollment, assessment, course records, library, transportation, so forth. You can have a whole lot of different tables in them that you connect using primary keys, which we'll get to in a minute. The advantage of, so taking in your different data sets that you create with all of your different vendors, and putting them into a large system, what we call a relational database, and then creating smaller tables of like-minded data, if you will, student data, and breaking that down into enrollment, program participation, course, test scores, assessment, is that then when I as a user go in, I only have to access whichever tables I need. Instead of having one huge data set called PIMS that has everything that you've submitted all year long, which if I wanted to get at fourth grade males who participated in a particular reading program, I'd have to go through every single record, every single element. And that would just take hours and hours and hours of processing time just to find those records. So what we do at the back end is create these relational databases with different tables that are small and easily searchable, easily connectable. So it makes the pulling and matching of data easier, saves on processing time. It's just much more usable. And again, I apologize if I'm stating the obvious. You all probably are both data entry and data users. You probably know this. Just trying to cover the gamut for you. So rows correspond to a single database record, like a student, like a course, like a teacher. The columns each represent different unique attributes, age, name, social security number, probably don't collect that here, your grade, your test score, the thing that is being measured. There are times when you'll have multiple records for a given student. So if you've got a course data set, for every student we'll have a different record for every course or subject they take, math, reading, Spanish 1, whatever. And so it's not that you always have just one record per individual. So you get to where mixing and matching and connecting can be kind of hairy at times. You have to think through all the things. So every table should have one or more columns designated as the primary key, which makes that record unique. And typically we'll think of student ID or maybe name. As one of thousands of Nancy Smiths, don't ever think that name is sufficient as a unique ID. And sometimes it might take 5 or 6 data elements to make a unique primary key. So let's look at this example. This student table, you've got the student ID. There's a different one for each of the students. We've got first name, middle name or initial, last name, date of birth, gender, race, ethnicity, location code. In Pennsylvania, that would be campus code elsewhere. And I just made those numbers up. It could be a 9-digit number here, I don't know. But and then district code. And those look like 3 different students, although, as is obvious with the name Smith, you could have some pretty common names and the date of births and stuff like that. So that looks like 3 different records. Oops. So just to show you in the database design concept, the class is the table, it's a student table. There would be one for staff, one for campus, whatever. The attributes are the columns, and the object is the row. Hardcore, the IT people talk in those terms. I talk about rows, columns, identifiers. As I said earlier, in the relational database, we're storing information both about the data and how it's related, how all the different tables are related. So again, we've got your 2-dimensional tables like an Excel sheet. Each table is tabular, rows and columns. Typically, the tables can be connected. You can connect one table to another table, or maybe one table, like the student identifier and demographic information, connect to multiple records in another. So there's all sorts of ways to mix and match the tables to get at what you want. I've got some examples in just a second. So just kind of a visual thinking through this. Again, just a very small sample of the types of data. But you can have different data sets or different Excel SQL tables, whatever, to cover particular things. So demographics, program participation, all the federal programs, all the district-specific programs, assessment data, whether it's your summative, formative, state, all the course information. And then likewise on staff, you've got multiple different types of information, demographics, experience, the courses they taught, campus, directory, budget information, financial enrollment, and those are usually aggregates, and then the district, some of the same things. And depending upon the policy question or data question, you might need to pick, 2 from the student, 1 from the staff, and 1 from the campus in order to get what you need to know in your analysis. So the primary key, everyone familiar with the primary key or want a primer on this? Well, I've got it up here, let me go through. You must be able to connect records from different data sets together correctly. Otherwise, bad data quality costs you a lot of money. If not, even if it doesn't cost money, it's going to cost you a headache by having somebody yell at you because the report is questionable. The key is a field or a combination of fields that's unique for every record in the table. So even in those situations where you have 3 records for a student because of 3 different courses, somehow the primary key has to add another data element so that it is a unique record. We need things to be named, defined, coded the same way across different tables, and this is where the PIMS data standards, this is where data standards are hugely important. And sadly, not all states have published data standards, and I've worked in states where the district folks have said, you know what, I'm doing my best to send you what I think you want, but I'm pretty sure that I'm calculating things differently than that district. But the people at the state level, they're just using the data because it came in, and that's why data standards are huge. Follow the PIM standards, and if there's questions, make the PDE folks, clarify it, because the use of it depends upon what you submit and how you define it. So let's look through this. Here's the table that we had before. So we've got the student ID, first name, middle initial, last name, date of birth, location code. So if we use student ID only, we think we've got 3 records. If we use student ID, first name and last name, maybe 3 records, but did somebody just type in Johnny because they know that kid is Johnny when it should have been Jonathan? Maybe these are actually the same kids, but because 2 different data entry people entered it differently, it looks like 2 different kids, but it's only 1. What if we have the primary key as student ID, first, middle, last, birth date, gender, race, ethnicity? So we go all the way across there. Well, look, was he born on April 7th or July 4th? When do we know? How can we figure out what's a typo so that, again, they're the same kid versus different kid? Is this a typo? Does this go with this school or that school? That's why you need as many data elements as you can when you're trying to mix and match records to make sure that you really got unique records and that they're not duplicates with errors. Any questions, comments, war stories? The student course table that I've been mentioning, you've got 3 records. I don't know why I keep moving all the way over. You've got 3 records for 1 student, 1, 2, 3, 4. Same campus, district, 3 different subjects. The course name, the course number, course section, because as you all know, you could have 5 different algebra courses if your high school is big enough. And then your grade. Well, if you just look at student ID, campus, district, and course name, that might be okay, but are you sure that every school, every district across the state uses the same name for the same courses? Hopefully there's again, data standards from PIMS. Typos, anytime you're matching letters, the typos can really kill you on that. Do you type out Spanish? Do you type SPN? So it wouldn't match if you're just matching on that. So I recommend using the course number and section number, because hopefully those are going to be more standardized and make sure that you have unique records. Want to go through some examples. I think I may not finish. Y'all may have to come back on Wednesday. Want to go through connecting records. So for me, when I was at TEA, we had relational database, and every year we had demographics _13 for 2012-13, program participation, assessment, and we had all these different variables. And then the next year, the data would come in, and the tables are set up the exact same way. We just have the file name as _14. So that I could mix and match across years, but I knew all the variables. We also had data standards because, as you know, race, ethnicity, dropout codes, exit codes, they change. So you have to adapt your program accordingly. So if we want to connect student records to analyze test scores of low-income students by district within a given school year, 2012-13. Again, in red, obviously, the student ID. That should be our best source of error-free data, although don't assume that anything is error-free when it comes to data. What other basic primary keys can you have? Well, program participation has student ID campus. It doesn't have all the demographics like name, date of birth, gender, race, ethnicity. Assessment, often that comes in from the testing company and not through PDE, so it probably does have all of this. It might have Social Security number. So to match all these three data tables to get the complete information that you need, because you need the low income status from this one table, you have to use primary keys on matching different sets of primary keys to match two different things. And then your outcome, the green variables, it says by district, so you need the district number, you need the low income status, and then whatever you need, the scale score or some alternative score. So you can see that as a user of this, we're touching a lot of different files just to get at a simple number, the average assessment score by low income by district. So it takes a lot of mixing and matching. So the primary key, the matching variables, are critical to make sure that you're getting unique and complete records. What if we wanted to look at, compare the average test scores across 2 years? So again, you have your demographics, you have your assessment for 2013 and 2014, pretty much the same variables, but you need to, again, get as much matching as variables as you can to get the accurate number across 2 years. Any questions, thoughts?
I don't understand why student ID is unique. Why a single field would be enough to be primary?
Because I don't believe, I've never heard of a case where they are 100% correct unique. There are times when districts, if a kid moves, one district won't let him go one day and another district tries to claim him, so he might actually show up. And as I said earlier, there are occasions, might be 1%, might be 2%. There are occasions where, because of the typos, they may not have been reconciled across districts or within a district. It may be safer than it used to be in states, and you all know the Pennsylvania data, so that may be all you need. I don't think that there's a field that we can trust 100%. And by adding in variables, my experience running analyses in Texas, admittedly years ago, each new unique variable just ensured the accuracy that much more. And even adding in Social Security number, which was not the unique ID, it was more like a demographic, that increased exponentially the match rate to assessment data. It's a matter of, you probably can, and it probably in most instances is correct. It may not be. And this just, adding in a few more variables just makes you a little bit more confident. Yes, ma'am.
Do you see a future being not only we have a PA secure ID, but we're going to end up with a table with federal IDs?
No. There's a law on the books. The feds cannot collect student information data. And I don't see that changing at all. Nobody, I don't know who wants to. I spent a year at the feds, and I promise you nobody there wanted to collect data. There was not enough staff to do what we needed to do, but there's no way the public is going to allow the feds to collect student data. Just aggregate, yeah. Yeah, I got bruised over that conversation a lot. Teacher files. Is it 10:30 or 10:45? I mean, the end of the session. Okay, thank you. I'll still talk fast. Teacher files. A lot of information on teachers, although not nearly as much as students, I don't think. Years of experience in district. You know, the whole mobile thing with students who are mobile across districts, teachers who are mobile, trying to connect across for the highly mobile students is really a challenge, and is with teachers. So what if we wanted to connect the student, the teacher, and the course to see if years of experience make a difference in student achievement? Because again, student achievement is what we always look at. Or even, from the student, you have student ID, campus, district, course ID. Well, apparently you have course ID twice. Course name, course section. The teacher, in the years of experience, you might just have the teacher ID and then the years of experience. And then on the course record, you know which campus, district, they taught that course, which course ID, which section number. And here, instead of the achievement, you're looking at the student grade, which some people like and some people say that's not an accurate measure of what they know, but we'll let somebody else deal with the politics of that question. But again, you can see that just on different data sets, you have either more or less information that make the matching and accuracy a little bit more challenging. So all of this is to say we need to be very careful that we use all of the data available to us to make sure that our summaries are as accurate as possible. And to show those of you at the data entry who may never see these tables how they're kind of parsed and grouped for me as a researcher analyst to make sense of it. I have no idea what your job looks like, all the data entry screens and however many you have. I know these, and likewise, we've got people at every step of the way, so I'm just trying to kind of help educate along the way of what we're all facing. Apparently, I'm not using my own handouts. Okay. So data quality, I really want to hit on this because as they mentioned earlier, it is just, it's huge. And I mean, it's quite costly when the data quality is a problem. And with that comes the responsibility to train everyone on how to use the standards, how to enter the data, how to check the data. And I know there's a lot of software out there that some states use, some districts use to do some basic data quality checks. In Texas, the education service centers, the regional units, are supposed to help with data quality checks before data gets submitted. I think some do more of that than others. The state, when they get the data in, should do, and does do, I believe, a lot of the data quality checking before we all sign off and use it. And I'm sure we've all got horror stories on that. But key to data quality first, data standards. Enter the data as it is in the data standards. Data standards aren't perfect, so you may need to raise questions, may need to change them. But we need to make sure that the data is all formatted in the same way for every district, school, student, teacher. As I mentioned earlier, in that state with no data standards, districts are doing their level best. They're working hard. They're submitting their data. They do not believe that their data is the same as the data in another district. So they have questions about data quality, which also means that they have questions about the data that the state actually reports and publishes. And without faith, there's a whole lot of work if no one has trust in it. You also need to, every step of the way, minimize the amount of time and money and resources used to cleanse the data and help with the interpretation for faster turnaround. I really think that the PIMS, the dashboards, all the work over the last 10 years on building these data systems is going a long way to improve the data quality. So we need timeliness. You need to get the data in on time so that everyone has a chance to check the data quality before releasing it. And in some states, there are consequences for untimely data, either in a bad dog, what we call the bad dog letter you should have, or a ding on accountability, something. There needs to be some accuracy, obviously, conformity, precision, correct representation, consistency and reliability, and a lot of that comes through the data standards. They've got to be consistent and reliable so that you submit the same data year in and year out. And then validity. Does the data actually measure what we say it's going to measure? And that's easy on assessments, on the tests. If we say we're measuring, I don't know, nose length, and yet the actual data has something to do with ears, it's not a valid measure. You can analyze it, you can use it, you can spin it every way you want, but it's not valid. We've got to make sure that all of our data that we collect is valid. So examples of data quality issues. We've got, you know what? How long did it take me to figure that out? In Demographics 13, Jonathan Rodriguez, born July 5th, 1998. In the assessment file, we have a Johnny Rodriguez, born the same date. Same kid, different kid. How do we figure it out? And that is often just a data entry, a familiarity. We always call him Johnny, In the course file, we've got a Jonathan. Maybe that's a typo, maybe it's a different kid. Again, the spelling of the names. Not a problem for me as Smith, but you all know that there are a gazillion names out there that really are challenged to spell, and we've got to enter them correctly. So that's just an example of very basic things to look for. Here's some PIMS coding. PIMS for race ethnicities, 1, 3, 4, 5, 6, 9, 10. Where I came from in Texas, every race had a category. I don't know what they do now with the new federal categories, but when I was there, everyone was a 1 or 0, a yes or no. So when I went to calculate percentages, I had to do some math, some regrouping of the elements before I could even get the counts and percentages. And so you've got to make sure that you're typing in the right fields. PIMS is a male-female. A lot of places I've been, it's 1, 0. Or some spell it out. And again, the more, I prefer 1 digit, because you type in 4 or 7 characters, typos are more prone to happen. Program participation, LEP, it's not just a 1 or 0 or a yes or no. Special ed, it's not just a yes or no. All of these I thought were interesting, and so that puts a lot of burden on you all to know the various codes and the not necessarily sequential codes, and I'm sure they change year to year. Key features of a data element that should be addressed in a data standard. Obviously the name, the definition is huge. Make sure that we all make sense of it in the same way. The code tables, the length, the data type, the pattern, the patterns, is it month, day, year, is it year, month, day? And the thing is, it's not just you all entering the data. A lot of this comes down to the vendor and how they created their data system and how they train you, what documentation they provide, and then somehow it has to be aligned to the PIMS data standard. So I know it requires a lot from you all to track all the different voices around all of this. Formula, here's one big one. Let's, send us a rate, send us attendance rate, send us passing rate, send us whatever rate. Well, how's it calculated? Because if there's 200 districts, there's probably 200 different, or at least 150 calculations.
Question, you had mentioned vendors. Are there any either state or national standards for vendors to follow? I know SIF and ISO compliance, things like that, but one of the challenges that I've seen with some of the vendor systems is because PIMS is collecting a field, like special ed here, Yes, no, why? The vendors are actually collecting that field as a standalone field, so they can map it as a one-to-one, rather than maybe deriving that from an IEP record that has a date and disability and all of that.
Yeah.
So it's a lot of dual entry for some
Yes.
staff, and then the IEP changes, and then they have to go in and manually update that special ed indicator, and then maybe they're not in sync anymore.
Exactly. That's a great example.
Every vendor kind of does it a little bit differently.
You know, the feds have started the Common Education Data Standards, and it's in year 5 or so, and more states are adopting. And we develop those with state, district, higher ed input, and more every year, the vendors, the SIS vendors, and other types of vendors are being both included in the process and adopting these, and more states are adopting these, or at least will map to these. It's hard to change over a state's data system totally, but this is becoming more of the de facto standards around education data, and I think there's like 5,000 variables in there now. And SIF has adopted them fully. EdFi, the state dashboard, uses the SEDS data standards. So it's the closest we're getting. When we started this, it was in full acknowledgement that state law also defines how to calculate different variables or what to collect for state mandates that may be different than the federal mandate. You know, the dropout rate that some states look at is different than the federal dropout rate. It's not mandated. And so your data system, PIMS, has to acknowledge both. And so it is hard to have just one set of variables for all vendors. But what's happening is that everyone's you'd built your longitudinal data system, and now we've got standards, and so now vendors and states are going backwards to try to align them. But I hear more and more vendors, at least the student information system vendors, are really working to align to SEDS. And, okay. So that was a great question. And so I kind of skipped over, I know you all know this page by heart, probably every page by heart, but this, I just wanted to highlight, you know, you've got your PIMS manual that does give the best data standards, and if you have questions, I challenge you to challenge PDE, because this has to be so clear and obvious to all of you as to get consistent, reliable data across districts. So don't consider this, you know, a black and white set in stone. It's a living, breathing document that can always get better, in my view. They may challenge me, but
If you have questions, tell Nancy's going to say.
yeah. I've challenged them on a few things already, so. So data analysis, I'll keep going. Got a few minutes. Data analysis, one thing that I've seen, again, in the past 10 years, all the states building these longitudinal data systems, the money goes to the IT people who are doing their best to create good collections, reduce the number of collections, standardize some of the data. You know, let's do a lot more online, fewer Excel. We're knocking it out of the park on IT for the most part. What we haven't really included was a lot of the users of the data. In part, in most states, there is not actually a research and evaluation division. Some states don't have analysts. Some states have a half of an FTE in 3 different program areas. Folks like the REL Mid-Atlantic ICF that do research, the field is still connecting the external researchers with the data systems to really look at how to use them, how to answer the questions that our policymaker needs. Our governors, our legislator, our chief state school officer, secretary of education here, they're all making decisions daily, with or without the data, with or without good quality data. We need to all work together to make sure that we collect the data in a way that can accurately, validly answer the policy question that they have. And that's a challenge, because that, again, is living, breathing, changing a lot. And one of those is really, truly understanding the types of data that you're collecting. You all just probably enter the data as best you can. You get the form, I need to ask it this way, I'm going to send it this way, with 6 numbers that aren't sequential in terms of race or whatever, you know. And I know how that changes over the year. We change definition, so we drop 7 and 8, and we just go to 9 and 10. You know, I understand how it gets done, but how to collect it isn't necessarily the same as collecting it to use it accurately. Not that anyone has bad intent, it's just a process. So one of the things that I think is important, and we haven't spent a lot of time on, is understanding data and the data analysis. How you analyze something really depends upon the data that you've collected. So we have data types. We have integers, whole numbers, positive, negative, grade level, the LEP indicator if it's a 1 and 0. Boolean, you're true and false. Again, it might be 1 and 0, yes or no. The character alphanumeric, we don't really want to analyze these. We just want to post them or count how many Nancy Smiths there are. According to Facebook years ago, there's maybe 4,000, I don't know. Not as bad as my brother Bob Smith, though, I think. And then the interval, the decimal, which is what we really spend a lot of time on, the assessment score, your GPA, height, weight, salary. Another way of looking at data types are categorical, your gender, whether male, female, unknown, changed, race, ethnicity, LEP, econ. Again, you have your open-ended, your alphanumeric. You have your ordinal, your grade level, first, second, third, fourth. Class ranking, where the distance between the student who was a valedictorian and the student who came in 10th may be huge in terms of performance in one school and maybe a 100th of a point in another school. And then your interval, your assessment scores, GPA, salary. How you're going to analyze those and what statistics you provide vary depending upon the type of data. I'm sorry, you can't really read this. I pulled this from the Pennsylvania report. A lot of percentage of his enrollment, percentage by student group, school name, that's just, you know, string alphanumeric. Phone numbers alphanumeric, even though it's all numbers. Grade level, and here we've got some counts, and here's an average, years of experience. So we've got a combination of all of those in there. Another way of looking at the types of analysis, like on the school report card, what we do, and I think a lot of what states can do, is descriptive statistics. We are just flat out describing something. And you know, I went to grad school where we were learning all sorts of statistical methods, ANOVAs, MANCOVAs, you know, all these things. And then I went to TEA, and they were like, you know, put up a report on students who failed in 5th grade and how they did in 8th grade, something like that. I was so excited to realize that I had the entire population of students at TEA. Whereas those research, the academic studies, are usually based on samples of students and you're projecting to the population. So for most of the data that PDE can put out, it's going to be descriptive statistics. You put your counts and percentages, averages. You can show numbers over time. You can look at trends. It's not a real hardcore statistical analysis. It may be hardcore to get there, but you know, it's descriptive, as opposed to the inferential statistics where we're taking a sample of students where you put some kids in one curriculum, some in another, and you study them over time and then project to the population. Most of what PDE can put out is descriptive statistics. So I did actually make it through on this. There is a lot more detail in our session on Wednesday on data quality checks and analytical checks that you can do to help check data quality and also look at your program.